Okay, we are looking at our 5.09 SBW. Let's go ahead and take a look at the SBW really quick. So on our SBW, we are given a parallelogram that is specified as a rectangle, and there are three statements provided that you can see there, where two of them are going to be true and one of them is false. What we want to do in the first three bullet points of our answer and our paragraph response is identify whether it is true or if it's a lie, and then justify why. Once we determine that information, we can also work with the final bullet point, which is to find the value of y by identifying the relationship of the diagonals of that particular rectangle. So I'm going to systematically go through a set of examples that is similar to each of the different types of statements that you are referencing in your diagram, and you can use that specific slide as a reference for determining not only whether your statement is truth or is a lie, but also the justification as well. What language would you specify or utilize if you find that it's true or if you find that it's a lie? So let's go ahead and take a look at the application problem that was given to us. So we have this football scenario, and we want to make sure that we practice with our knowledge of rectangles so that we can do really well at the game. We recognize that we need the properties of a rectangle, of course, in order to achieve success here. So keep in mind that this is our reference slide for our properties of our rectangle, and specifically we want to emphasize two distinct properties as well that make a rectangle actually a rectangle. One is the diagonals of a rectangle are congruent and that we have four right angles as well. We also don't want to neglect the fact that this is a parallelogram as well, so it possesses all of these properties that otherwise make it a parallelogram. So with that being said, with those 7 properties there, let's go ahead and examine a particular type of problem that is involved in this particular context. So we have the running routes that we have available here, and we have the two angles that they're asking us to examine, the measure of LTA and the measure of BTA, which is represented here and here. And the orange doesn't necessarily show up very well, so I'm just going to emphasize that it's right here and it's right there. So let's go ahead and take a look at that. Is statement 1 a truth or a lie? So the statement that they're giving us is that the measure of these two angles is equal. Is that a statement that is truth or is it a lie? Well, in our particular case, we can identify that it is going to end up being a lie. Now, the two angles again are represented here and here. Why would that be a lie? Well, we know that it's a rectangle, and we can state that the angle LTA and the angle BTA are consecutive angles. Now, what does consecutive mean? Well, when you talk about consecutive, you're referring to angles that share a common side and a common vertex. So they're consecutive because they're next to each other. The other thing that you have to consider is that consecutive angles are supposed to be supplementary. Consecutive angles are supplementary. But they're not always congruent. So the problem here is that they're stating that those angles are equal to each other, and this is just not going to be true in the context of a rectangle, because the diagonals would need to be perpendicular for us to guarantee this, right? So just a little bit of a fact here. The diagonals would need to be perpendicular. So the diagonals are not necessarily perpendicular, or just not perpendicular, unless it's a square or rhombus. And that is not what is given here. It's a rectangle. So all we can say is that, well, it's only the case that they could be congruent if the diagonals are perpendicular. That is not a property of a rectangle specifically, so we cannot say that those are equal angles. We can say that their sum is equal to 180, however. Looking at the exact same setup, let's go ahead and just look at the other cases as well that we can examine. For example, we can also take a look at this statement. Is this actually truth or is this a lie? Well, in this particular case, we have an example of a statement that is actually a truth. And the reason why it's a truth is if you look at FB and you look at BA, FB and BA intersect, in this case, at the angle located at B. Now in our case, we could be specific about that angle, or we can be very generic about that angle. In our case, we can say angle B, just for the point of bringing up the vertex itself. In parentheses, maybe on the side, angle B is referring to the entire angle, right? So I am going to specify that's the entire angle there at the corner. And of course those segments intersect there. What we know about the interior angles of a rectangle is that the interior angles of a rectangle are 90 degrees. So that means that the measure of angle B has to equal 90 degrees. The reason why they have to be perpendicular then is they would only be perpendicular if they met at a 90-degree angle. That is the reason why the two segments are perpendicular, because the angle located at B, which is the common vertex here that we have, the angle located there in its entirety is a 90-degree angle, which is why this is actually a true statement. This is a form of justification that you could use to kind of verify why the two segments happen to be perpendicular. Remember that this symbol is the symbol for perpendicularity, okay? So don't forget what that symbol means. Let's go ahead and take a look at another statement. Is this statement actually true or is this false? So in this statement, what we want to reference is that FT is equal to AT. So FT is here and AT is here, and this is actually also a truth. Now, a couple facts that I want you to be aware of, that I want to remind you of. Some of the properties of a parallelogram. Diagonals bisect each other, right? So diagonals bisect each other. That is a parallelogram property, and that's exactly what we're showing here. And what that means is it divides the diagonals, each diagonal, into two equal lengths or segments. So our explanation is because the diagonals of the rectangle bisect each other. So I'm literally pulling that language from my reference slide that talked about the properties of a rectangle or a parallelogram. I'm pulling that and using that as my justification. So that would be my why. In the final statement, we want to figure out, in this case rather, what the value of y is, and we want to know what the relationship is between the two diagonals. So we can work that relationship out. We know that in a rectangle, the diagonals of FA and BL are going to be congruent. So that means the relationship of the diagonals of a rectangle are equal lengths. So equal lengths means I can take my two expressions for each diagonal and I can set them equal to each other, and I have an algebraic equation where I can solve for the value of y. So I'm going to subtract 3y on both sides, And I can subtract 2 on both sides as well. And that allows me to arrive at 2y, which will then equal 10. Then I can divide both sides by 2, and I end up with y is equal to 5. So I know that y is going to equal 5 in this case. So the diagonals are going to be equal in a rectangle, and that's a unique property that I highlighted in orange in that previous slide that I referred back to over the properties of rectangles. So I have outlined very carefully and very strategically every single example that you've seen is a good reference for each of the bullet points that you are now going to be targeting yourself. So I encourage you to go back to each single example as I did in that order to help assist you with answering your statements and using the precise language or justification or reason as to why you believe it to be a truth or you believe it to be a lie. And that is going to be your 5.09 SBW help video.